I have made a lot of videos about this rule recently. I don't know why, but the SAT seems to be very obsessed with similar shapes in multiple dimensions. It's kind of something I never really learned in school, but now that it's on the SAT, we all got to get comfortable with it because it seems to be just a hard question that they love. So I'm not going to go into details about the formula. You can watch my lesson on similarity to learn more about it. Just search my channel. But here's how it goes, right? So right rectangular prism P is similar to right rectangular prism Q. The volume of prism P is 972 cubic centimeters, and the volume of prism Q is 36 cubic centimeters. One edge of prism P has a length of 12 centimeters, with the length in centimeters of the corresponding edge of prism Q. So the basics here is that P is bigger than Q, right? So we're going to take the side length of Q. So this is the length, and we're going to take the side length of Q and multiply it by some constant K, let's just call it K, to get a side length of P, right? So basically another way we might say this in normal English is that the prism P is 3 times as big, 5 times as big, 7.2 times as big as prism Q, right? That's essentially what the K is it's that number. How many times bigger is P than Q? So you might be thinking, okay, well, it says P is 972 and 36 is the volume of Q, so we just divide and we'll be able to figure out how many times bigger it is. No, because as we move through multiple dimensions, if we move into something like surface area, then we have to use a different version of this formula where we square the K, right? It's 2 dimensions, so whatever the size difference is, it's going to happen twice. It's going to square. And so when we go to volume, and you might expect it, it's going to be K to the third. If you have questions about why, watch my lesson. I'm not going to get into it. It's one of those things you either memorize it or not. So hopefully you know what I'm talking about. Now it's just a matter of me reminding you to use it. But essentially now we can plug points into equations because we have an equation to plug into. We don't know the K to the third, but we have Q is 36 and we have P is 972 because those are both volumes. Now I'm going to simplify, right? So let's just go to my regular calculator here. So 972 divided by 36. So you would have done this anyway, but you would have gotten that K cubed is equal to 27. And then many people are just going to put that as the answer, right? Or they're going to multiply one present. You're going to, I guess, divide by 27. So you're going to get some weird number here, but it doesn't matter. It doesn't matter. Point is, if K cubed is 27, now we have to take the cubed root of this, and hopefully you just know cube root of 27 is 3. So now we have a new relationship. And now that sentence I kind of said at the beginning, I can say it much more clearly. I can confidently say, I might have even used this as an example, but I promise you at the beginning it was just a random example, that prism P is 3 times as big as prism Q. But when I say that, I mean the dimensions, the length, the width, the height. If I were to count the volume, it's actually 27 times as big. So this is the thing, is it's even that sentence gets hard to understand, and you have to be clear about what you mean. Do you mean the volume? Do you mean the surface area or the regular area? Do you mean the length? So we can kind of go back to here now. We have 3 is our K. We know that P, the length of P is 12, so we don't know Q. So we'll put that as a variable, and that's 12. So Q divide 12 by 3, and it should be 4. Let's double check. Yeah, there you go. So the bad news, good news, bad news. The bad news is this is a kind of weird thing. I don't love this topic. It's kind of conceptual. You have to be able to like think about multiple dimensions and understand why this is what it is. That there is a kind of factor, a growth factor between these two things, but that it's going to show itself very differently depending on how many dimensions we're thinking about. So that's kind of the bad news, is that that's difficult for a lot of people to think about. And like I said, for myself, this was not a topic I learned or I remember learning in high school. So no knock on my math teacher, but like, I just don't think this came up. The good news is it's pretty predictable. Once you know this formula and I guess the 3 formulas and how they relate, it ends up just being like, write them down, plug them in, solve for X, that kind of situation. So this hard question becomes very routine, to the point where like, if I saw this on a test now, I'd be like excited about it because I'd be like, this is going to be a hard question that I'm about to get right in a very easy way. So hopefully I helped with that. Like I said, Go search my channel for my lesson on similarity. It starts with triangles, but it also gets into this particular rule. And so hopefully once you memorize it, this question will be easy for you next time.